Let's take a look at the chain rule. Now, I'm not going to go over why this works. They just do a pretty good job describing that in the book, and I'd refer you to that. If you were in the full calculus class, we would go over that in a little bit more detail, but we're going to take a look at how to use it. Now, there's going to be different versions of this chain rule that we're going to use. The first one is referring to the formula we have. Remember, if you've taken the derivative of x to a power, you take your power, put it out in front, and then you lower it by 1. So nothing exciting there. But instead of just having x to a power, what if we have like x minus 3 to a power? Now the u can represent anything. It's not a single variable, but it can be anything. So if we have anything to a power, and that's pretty vague, isn't it? I mean, there are some conditions, it has to be differentiable, in certain, and all this and that, continuous, but basically you got something to a power. Well, you can take your power, put it out in front, and then you lower your power by 1. Well, no, so far no change. But then you multiply it times the derivative of u. So that's going to be the rule we're going to work with. And let's look at our first problem. We've got y is equal to 3x to the 5th minus 2 to the 3rd power. Now again, we got something to a power. Well, this is going to be our u, what's inside the parentheses. So we need u prime. Well, the derivative of that would give us 15x to the 4th. Take your power, put it out in front. 3 times 5 is 15, lower it by 1, and negative 2 drops away. And so from our formula, and I won't write the formula down many times because it's pretty straightforward, I think. We take our power, put it out in front. So take 3, put it out in front. The u remains as is, so we got 3x to the 5th minus 2. Lower it by 1, so it becomes 2, and then you multiply it times the derivative. So multiply it times u prime, which would be 15x to the 4th. Now typically you put the number out in front. If you got extra power like that, you put it out in front too. 3 times 15 x to the 4th, and we got 3x to the 5th minus 2 to the 2nd power, which gives us, what is that, 45? X to the 4th, 3x to the 5th minus 2 squared. And that's our answer. Now let's take a look at this one. We've got f of x is equal to 5x minus 3 to the 1/3 power. Well, we got something to a power. So u would equal to what's inside the parentheses, which is 5x minus 3, and u prime would be 5. So from our formula, this is probably the last time I'll write it down, f prime, take our power, put it out in front, so we got 1/3 there. U remains as is, 5x minus 3. Then lower this by 1, so it'll be 1/3 minus 1 times u prime, which was 5. Now I'll take 5, put it out in front, so we got 5/3. And this is 5x minus 3. 1/3 minus 1 gives us negative 2/3. And since it's a negative exponent, I'm going to take it down to the denominator. So this becomes 3 times 5x minus 3 to the positive 2/3. And that's our answer. Shift my position here a little bit. Been sitting too long. There. Yeah, let's take a look at this one. We've got y is equal to the 5th root of 7x squared minus 4x plus 2. Well, we can rewrite this in rational exponent form, fractional power form. We've got 7x squared minus 4x plus 2, and we'll rewrite it to the 1/5 power. So now we got something to a power. So from our chain rule, we're going to take our power, put it out in front. What's inside the parentheses remains as is. We'll lower the power by 1, and then we'll multiply it times the derivative of what's inside the parentheses. Well, got 7x squared minus 4x plus 2. 1/5 minus 1 gives us negative 4/5. And the derivative of 7x squared minus 4x plus 2 gives us 14x minus 4. Well, this negative exponent, I want to take it down to the denominator. 5 is already down there. So this becomes 7x squared minus 4x plus 2 to the positive 4/5. And I got 14x minus 4 up on top there. Now, if you can see nothing would factor away, then you don't need to worry about this. But typically, if you have a GCF, you factor that out. See if anything pops out at you. I factor out a 2. I see that nothing can cancel. Different books will do it different ways. A lot of them will factor the top and factor the bottom like this and leave it that way. Some will leave it in this form. Couldn't tell you what this book does. But that's our answer. Let me save this. Let's see, chain rule. Page 01, PDF. There we go. And there it is. Okay, so let's look at our next problem. So we've got f of x equals 7 over x squared minus 9 to the third power. Well, chain rule doesn't say we can have parentheses to a power down here, but I can take this entire piece here and move it up on top. Now when I do that, that becomes x squared minus 9 to the negative 1/3. So the sign of the exponent changes. And now we can use our chain rule. Now numbers out in front just stay out in front. Okay, chain rule says take your power, put it out in front. Whatever's inside the parentheses, leave alone. Lower this by 1. And then multiply it times the derivative of what's inside the parentheses, which is the x squared minus 9. So that gives us negative 21, x squared minus 9 to the negative 4, times the derivative of that, which would give us 2x. Now I'm going to create a fraction, because I want to take this negative exponent part down below. So that gives us x squared minus 9 to the positive 4. Negative 21 times 2 gives us negative 42x. And that's our answer. Let's take a look at this one. We got f of x is equal to x to the 5th, and x minus 7 to the 8th. Well, this is the product rule. We got this times this. So this is p and this is q. Now for p prime, that would be 5x to the 4th. Now to find the q prime, I have to use a chain rule. So I've taken, because we got more than just x to a power. So I'm going to take my power, put it out in front. What's inside the parentheses remains as is. Lower this by 1. And then multiply it times the derivative of what's inside the parentheses. So that gives us 8 times x minus 7 to the 7th power times the derivative of that is 1. So that just gives us 8 times x minus 7 to the 7th power. Well, our product rule, we got p prime q plus pq prime. P prime is 5x to the 4th times q, which is x minus 7 to the 8th, plus p, which is x to the 5th, times q prime, which is 8 x minus 7 to the 7th. Now let me double check that. My eyes sometimes cross. Q is that. Okay, P is that. Q prime is that. Okay. Well, now we're going to factor out what they have in common. What do they have in common? Well, this is considered one group. This is considered one group. Why do I consider them separate groups like that? Everything in here is multiplication. 5 times x to the 4th times x minus 7 to the 8th. This one's x to the 5th times 8 times x minus 7 to the 7th. Well, if I look at the first group and second group, they both have an x to the 4th. And this one has x minus 7, 8 of them. And this has x minus 7, 7 of them. So I can factor out 7 of them, like that. Okay, my first group here, I'm left with a 5. That x to the 4th is gone. I had 8 of these x minus 7s, and I took 7 of them away, so that leaves me a single x minus 7. Now over here, I had 5 x's. I took 4 away, so that leaves me a single x, so plus x. And I had 7 of these x minus 7s, and I took all 7 of those out. So we got x to the 4th times x minus 7 to the 7th. 5 times x is 5x. 5 times negative 7 is negative 35 plus x. Okay. 5x plus x gives us 6x minus 35. Not that the position of it matters any, but I'm going to go ahead and put the 6x minus 35 in front and the x minus 7 to the 7th behind. I think it just looks a little bit cleaner. And that's our answer. Let me save that. And let's look at the next problem. We got 3x squared over 2 minus x to the 5th power. Let me grab a drink. Throat's starting to dry out. It's not pretty, but we got something to a power. We got this entire fraction to the 5th power. So the chain rule. And I didn't write down what it was. Y. Y equals. So find our derivative. Take our power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then you multiply it times the derivative of what's inside the parentheses. Well, if I look at what's inside parentheses here, this is the quotient rule. This would be P, and this would be Q. So I need P prime. P prime would be 6x. I need Q prime, which would be negative 1. So the formula is P prime Q minus P Q prime over Q squared. Excuse me. So I got 5 times 3x squared over 2 minus x to the 4th power times P prime, which was 6x, times Q, which is 2 minus x, minus P, which is 3x squared, times Q prime, which was negative 1, over Q squared. Double check that. P prime 6x, Q is 2 minus x, minus P is 3x squared, Q prime is negative 1. Okay. So I got 3x squared over 2 minus x to the 4th times. Now, I could factor out a GCF. Again, we have one group here, everything's multiplication, and we have one group here, everything's multiplication. Looks like they both have a 3 in common and an x. So I can bring out a 3x. Now here I'm left with a 2 times 2 minus x. Now a negative times a negative is a positive, and I took away that 3 and took away one of these x's, so that leaves me a single x. Over 2 minus x squared. 3x squared over 2 minus x to the fourth. Let's see, 3x there. 2 times 2 is 4. 2 times negative x is negative 2x plus x over 2 minus x squared. And we got 3x squared, 2 minus x to the fourth. And then 3x times negative 2x plus x is negative x. So we got 4 minus x over 2 minus x squared. Now, this right here, when you got a fraction to a power, you can take the top part of that power. So I got 3x squared to the fourth power over 2 minus x to the fourth power. And then here I got 3x and 4 minus x. And this is 2 minus x squared. I'll put the 5 up on top. And I'm going to merge these all into a single fraction. So I got 5 here times 3x squared to the fourth power times 3x times 4 minus x. And down below here I have 2 minus x to the fourth power and 2 minus x squared. Well, I'm going to go ahead and apply this fourth power to both of these. So I got 5 times 3 to the fourth times x squared to the fourth. If everything is multiplication inside of a parentheses and you're raising it to a power, you can take everything to that power. Times 3x and times 4 minus x. Now here, when you got 2 minus x to a power times 2 minus x to a power, you add the exponents. So that gives us 6. Okay, so that's 5 times 81 times x to the 8th. You're raising one exponent to another exponent, you multiply them. Times 3x and 4 minus x. So we got 2 minus x to the 6th power. Let's see, 81 times 3 is 243 times 5. 1215, assuming I did all my multiplication correctly, which is sometimes doubtful. And x to the 8th times x gives us x to the 9th. 4 minus x. Hard to say where they stop. I really don't like how these are in a wrong form, but that's me just being anal, I think. What you can do is you can factor a negative 1 out, and when you do that, it flips the sign of both of these. So that becomes negative 4 plus x. You can do the same thing down here, factor a negative 1 out, and that gives you negative 2 plus x. Now up on top here, the negative we can just put out in front. So I got negative 1215, x to the 9th, and this I can flip around and it becomes x minus 4. Now down here I can take the negative 1 to the 6th power and it disappears, and this just becomes x minus 2 to the 6th power. And that's about as good as we can get. Now again, it kind of depends on the different author where they might want to stop at on that. But that's a nice problem. Okay, so let's save it. And let's look at the next problem. Excuse me. Y is equal to 7x squared minus 5x to the 3rd power, and we're given this point 1/8. Now it says find the equation of the tangent line. We've done this before in 2 or 3 other sections, so there's nothing exciting here, but the finding derivative is the only change. Remember, our first step is to find our derivative. So we're going to take our power, put it out in front. This is a chain rule because we got parentheses to a power. I'm going to have to update it, Vasto, to leave me alone. 7x squared minus 5x. Lower our power by 1. And then we multiply it times the derivative of what's inside the parentheses, which is 7x squared minus 5x. Okay. The derivative of that gives us 14x minus 5. Now, if you want to simplify it, that's fine. But in our second step, we change our y prime to m, and we plug in the x part of our point. So you don't have to simplify it. So we'll plug 1 in for x. So we've got 3 times 7 times 1 squared minus 5 times 1 squared times 14 times 1 minus 5. Well, 1 squared is 1 times 7 is 7 minus 5 times 1 is 5 squared. Over here we got 14 times 1, which is 14, minus 5 gives me 9. 3 times 9 is 27. And 7 minus 5 is 2, so we got 2 squared, which gives us 27 times 4, which gives us 108. Let me double check that. Okay, 1 there, 1 there. 7 minus 5 is 2, is 4, that's 12. 1 there, that'd be 9. 18, 1, 108. Okay, yeah, 108. Well, step 3. We want to plug in the given point for x and y and the m we just found, and then solve for b. Well, let's scroll up. This is x, and this is y. So put 8 in for y and 1 in for x. So we got 8. M was 108, and x is 1, plus b. Then we want to solve for b. So 108 times 1 is 108. Take the 108 over the left side, becomes negative 108. Subtract those, and we get negative 100. Now we can't forget step 4. Step 4 is actually write our answer down. We just said m was 108, and b is negative 100. And that's our equation of the tangent line at that point. Let me save that. Then we'll look at the next problem. Okay. Got y is equal to 5x minus 2 over the square root of x plus 2. And 711. It says find the equation tangent line to the graph of the function at the given point. Well, we need to find derivative, and we don't work well with radicals, so let's go ahead and rewrite that. The square root of x plus 2 is x plus 2 to the 1/2. Now this is a quotient rule, because we got something up on top, divide by something on the bottom. So this is going to be p, and this is going to be q. The derivative of 5x minus 2 is 5. Now for q prime, this is going to be a chain rule. We got parentheses to a power, so something to a power. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside the parentheses. So that gives us 1/2 x plus 2 to the negative 1/2. Derivative of x plus 2 is 1. So I'm going to take the x plus 2 to the negative 1/2 downstairs to the denominator. Becomes x plus 2 to the positive 1/2. Okay, so now we're ready for our quotient rule. So p prime q minus p q prime over q squared. P prime was 5. Q is x plus 2 to the 1/2. minus p, which was 5x minus 2, times q prime, which is 1 over 2 times x plus 2 to the 1/2, all over q squared, which was the x plus 2 to the 1/2. Now, technically, we wouldn't have to simplify this because we're going to plug in our number to find our m, but I want to show the simplification on this because it's kind of a neat one. Gets you working with problems of this type more. To begin with, we can't have a fraction inside of a fraction. So we're going to multiply everything by 2 times x plus 2 to the 1/2. So I'll multiply this first piece by it. Multiply times the 5 times x plus 2 to the 1/2 minus 5x minus 2, 1 over 2 x plus 2 to the 1/2. Multiplying it by that also. And we're going to multiply the bottom part by it. So I got 2 x plus 2 to the 1/2 times. Now what we have down here already is we've got 1/2 raised to the second power. You multiply the exponents, so 1/2 times 2 gives you 1, so this is the first power. Okay, 2 times 5 is 10. X plus 2 to the 1/2 times x plus 2 to the 1/2 gives you x plus 2 to the 2 over 2 minus, that cancels with that. So we're left with 5x minus 2 inside of parentheses, because that negative has to flip the sign of both of those. And down below here, we add the exponents. 1/2 plus 1 gives us 3/2. So this becomes 10 times x plus 2. That negative out in front of that flips the sign of both of those. So it becomes negative 5x plus 2. Multiply the 10 through. So 10 times x is 10x, times 10 times 2 is 20. Minus 5x plus 2 over 2 times x plus 2 to the 3/2. 10x minus 5x gives us 5x. 20 plus 2 is 22 over this. Okay. That's our derivative. Like I say, I just wanted to show that so you get used to that different way of simplifying. Well, step 2, we want to find our m. So we're going to plug in the x part of our point, whatever it was. Looks like our x part of our point was 7. So let's go plug 7 in. So we got 5 times 7 plus 22 over 2 times 7 plus 2 to the 3/2 power. So that gives us 35 plus 22 over 2 times 9 to the 3/2 power. Well, up on top, that gives us 57, I believe. On the bottom here, I can split this up. I can take the numerator, the 3, and put it on the outside of the parentheses. So we got 9 to the 1/2 there. Okay, so we got 57 over 2, and then 9 to the 1/2 is the square root of 9. So that gives us 57. Now square root of 9 is 3, so we got 2 times 3 to the 3rd. 3 to the 3rd is 27. So we got 57 over 54 for our m. Assuming I didn't make a math error. Let's see, 9 square root of 9 is 3, 27, 54. No, it looks right. Okay. Step 3. Into y is equal to mx plus b. We want to plug in our initial point. X is 7, y is 11. And then our slope was 57 over 54. and x was 7 plus b. I'll be lazy. Okay. 57 over 54, so 57 divided by 54 times 7. And math, enter. 133 over 18 equals b, or plus b. Now take that over to the left side, and we got negative 133 over 18. So 11 minus 133 over 18. Math, enter. 65/18. And so step 4. Write our answer down. Well, m, we said, was 57 over 54. And b was 65 over 18. So that'd be our answer. And let me save that. And let's get a new page. And let's look at our last problem. Okay, so we got a is equal to 2,000. 1 plus r over 4 to the 40th power. And it says 2,000 is put into an account with an annual interest rate of r in decimal form, compounded quarterly. At the end of 10 years, the balance a is given by this formula. It says find the rates of change of a with respect to r. So we're gonna take the derivative of a with respect to r. Well, if we have a number out in front, the number stays out in front, remember? This is parentheses to a power, so chain rule. Take our power, put it out in front. What's inside the parentheses remains as is. Lower our power by 1. And then we multiply it times the derivative with respect to r of what's inside the parentheses. Okay, 2,000 times 40 gives us 8 with 4 zeros, so 80,000. 1 plus r over 4 to the 39 times, and derivative of 1 is 0, so that drops away. Derivative of 1/4 r is 1/4. Well, 80,000 divided by 4 gives us 20,000. 1 plus r over 4 to the 39th power. So that's our derivative. That's our rate of change. Then it says find that when r is equal to 0.02. So they want us to take that formula and plug in 0.02. Now they also want us to plug in 0.10, and they also want us to plug in 0.15. Well, you can do these on your calculator. If I plug this into our y equals. Now, actually, if you don't have the calculator, let me go ahead and give you the steps. So I got 20,000 here. Then 1 plus 0.02. Actually, this isn't too bad by just normal means. So let's plug that in our calculator. This one here will be 20,000 times 1 plus 0.1. Try it again. 0.10. I'll get it right here yet. Divide by 4 to the 39th power. And this one will be 20,000 plus, or times 1 plus 0.15 divided by 4 to the 39. Okay, to do this on our calculator, if I type in 20,000, begin with, then do a beginning parentheses, that was 2,000. Okay, 20,000, beginning parentheses, then 1 plus 0.02 divided by 4, closing parentheses, caret 39. That should be my first one. Then enter. I get this. So our rate of change would be 24,294.41. Now if I plug in 0.10, I can do a second enter to bring up the previous entry. I can do an up arrow and right arrow and go put it on the appropriate place. And this is 0.10. Enter. And we get that. So it'd be 52,391.49. Yeah. Now we'll plug in 0.15. So I'll do second enter, bring up previous entry. And I'll go over. I put in 0.15 there. And enter. And we get this. So we get 84,055.49. And those will be our three answers for A, B, and C. Now, remember what we're finding here is we're not actually finding A. We're finding the rate of change of A based upon those values. So, let me save this. Of course, it comes up with weird results because I made up some bogus numbers, but. And then let's bring up the recorder, first one anyway, and stop it. And then bring up the second recorder.